Welcome to today's lesson. My name is Siamasaka Kendens. I'm going to take you through another very interesting lesson today. Actually, look at organic chemistry. So we go straight into the lesson. Actually, today we are going to look at organic chemistry, and we are starting with the homologous series. Homologous series are a group of compounds of similar structure in which each member differs from the next by the presence of an additional CH2. So in a compound, the one which follows actually will differ with CH2. They will differ where there is an increase in one carbon as well as two hydrogen atoms. And so that's what's known as the homologous series. And so the properties of compounds in homologous series are such that actually they have the same general formula as we saw in alkenes, acids, that's organic acids, as well as the alcohols. They have the same general formula. Also, they have the same functional group. Also, their physical properties are such that the melting point, boiling point, density generally show a gradual change with the increase in molecular formula in the series. So this is very important. And then the properties of compounds in homologous series also have chemical properties that show similarities due to the presence of the pressure of the functional group. Also, consecutive members of the series differ from each other with the actually CH2, as I indicated earlier, and which is actually known as the methylene group, and their molecular weight might differ also by 14 units. So these are the properties of actual homologous series. So the physical properties of alkanes, actually alkanes are non-polar molecules that are soluble in non-polar solvents. So now we are through with the homologous series. So we are looking at now alkenes. Alkanes actually are non-polar molecules which are soluble in non-polar solvents. Okay, and they are also colorless. They do not have color, as well as they are less dense than water, so they float on water. Their melting and the boiling points in shorter chain alkanes is very low, and then it increases as the carbon atoms increase. Okay, and then the chemical properties of alkanes are that they are relatively unreactive with strong acids and strong bases. So they do not actually react with strong acids and strong bases, as alkanes. Also, they react rapidly with the oxygen, hence they are used as fuel. So when they are combusted or they are burnt in the presence of adequate amount of oxygen, they actually rapidly combust or they rapidly burn. Okay, and so they are used as fuels. The combustion reaction, we are going to look at it, as well as the substitution reaction, which these alkanes undergo. And so the combustion of, for example, we can give an example of the combustion of one alkane, methane, in the presence of oxygen, that's the plus oxygen, we produce carbon dioxide plus water. And if we are to write this one in a chemical form using chemical symbols, so we have methane here plus oxygen, and we have carbon dioxide plus water as a gas. So this is very important because all alkanes, actually, if they are burnt in adequate amount of oxygen, they will produce carbon dioxide and water vapor. And so during incomplete combustion, also we are giving a case of methane burning an adequate amount of oxygen. It will actually convert then to produce carbon monoxide and water. And so And incomplete combustion is where actually there is adequate amount of oxygen for the burning process. And so these alkanes actually will produce carbon monoxide during incomplete combustion, as well as produce also water. So during the substitution reactions of alkanes, actually they undergo substitution reaction with the halogens. That is the actually elements which are in group 7 of the periodic table. Okay, these are the halogens. We have chlorine, iodine, bromine, fluorine. So these are the halogens which are in group 7. So actually alkanes can react with these by swapping one atom from actually an alkane with this halogen. So that is always in the presence of ultraviolet light. So this is very important because this reaction is actually facilitated by light. So in the presence of ultraviolet light, actually a halogen will react okay, in this manner using the substitution method. And so let me give an example of one of the alkanes here. So, and one of the halogens. So methane plus bromine, get methyl bromide plus hydrogen bromide. And so the substitution is such that here, where methane, now there are 4, that is carbon 1 and hydrogen 4 atoms here. So 1 halogen here, bromine, will substitute 1 hydrogen here. So we're going to remain with 3 actually hydrogen atoms. And then bromine would have replaced one of them. And this is what is known as the substitution reaction. So the one which has been substituted will react with the other bromide to form actually hydrogen bromide. So this is the reaction of actually during the substitution reaction of alkanes. So this same reaction can be written in structure form. And as we learned earlier on, we said this is methane. We remember the other lesson we looked at actually how to write the structure formula. So methane is written where there are 4 bonds around the carbon, and we have hydrogen actually on each bond, plus the bromide there too, because this is the atomic. As you can see it from here, we need to have 2 bromine atoms. So these are the ones. And then the replacement, we said this actually 1 hydrogen atom here will be replaced by 1 bromine atom. So this one comes here to form what is known as the methyl bromide. And so then the other hydrogen will be the one which will replace the other bromine here and form hydrogen bromide. So basically, the main 2 reactions that alkanes undergo are substitution reaction as well as combustion. They are not reactive because they don't have actually the capability for them to take on more atoms. And so because of their reactivity, they merely burn, and the only reaction they undergo is by substitution. And so I thought this is very important for us today to look at. And now we'll go straight to look at where we can use these alkanes. Actually, we have many uses of alkanes. I've just listed a few here. They are used on daily basis. So we use them actually for making fertilizers, also for fuels in homes, electricity generation, as well as in vehicles as fuel, as well as in the refrigeration process, also as solvents for organic trees, actually making organic solvents, as well as glue. So, but there are many more other uses where alkanes are used. They are used vastly, but I thought maybe we can just get a few of them. And so we'll continue looking at these interesting lessons. So you can subscribe to my YouTube and then continue receiving such lessons. I thank you.